All right, guys, we're going to look at quadratic functions, a polynomial expression in which the exponent in the leading term is 2. Okay, so here we have this polynomial function, x squared plus 6x plus 5. It is a trinomial with the highest degree of 2. Now here, if you recall, you have ax squared plus bx plus c. So here our a is 1 and our c is 5 and our 6 is our b. So we can do the product sum, a times c. So 1 times 5 is 5. And then our b is 6. What are the factors of 5 that will add to give me 6? So that's going to be 5 and 1. So we're going to use those numbers. So since our a is 1, all we have to do is take these numbers and plug it in to make binomials. So we ask ourselves, what times what gives me x squared? So x times x. And then I'm going to take the plus 5 and the plus 1, and then that will give me my answer. I can check it by distributing. So I have x plus 5 times x plus 1. That will give me x squared plus x plus 5x plus 5. Then I combine like terms and I get x squared plus 6x plus 5. So this is the factored form and this is standard form. So we did not change the problem, we just rearranged it, okay? So when you are working on this, just remember your problem should always be able to check and go back to the original problem here. So if we look at this problem here, we do our product sum. We're going to have 12 and 7. So we ask ourselves, what are the factors of 12 that will add to give me 7? So 1 plus 12, that's not 7. 2 and 6, that makes 8. 3 and 4. So 3 and 4 are going to be my factors. So I'm going to have x plus 3, x plus 4. So if a is 1, think of two numbers that multiply to give you c, but add to give you b. Okay? So let's move down. When a is greater than 1, you factor trinomials, and we're going to use the Berry method here. You may have a different method that you have used in the past, and if you remember it and you know how to do it, then go ahead. Look for a GCF first. This is very important that you check for that GCF first, or this method does not work. So you're going to multiply a and c together. Think of two numbers that multiply to give you AC, but also add to give you B. Plug into your two binomials, look for any GCF, and squish them like a berry. Okay? Then it's important that you check your work. Okay, so if we look at this first one here, give it a try using the method above. So pause the video, see what you can do with this first problem here. Okay, so hopefully you realize that this was x minus 1 times x minus 1. And ask yourself, is there a way to simplify that? Well, they're both the same, so I could write it as x minus 1 squared. Okay, so if we look at this polynomial here, we first off, we notice that a is not 1. So our first step is to check for a GCF first. So what will go into 4, 22, and 10? 2. So that's going to give me 2x squared plus 11x plus 5. Okay, you can distribute and check. 2 times 2 is 4, 2 times 11 is 22, and 2 times 5 is 10. Okay, now this 2, I'm not squishing. This was that first GCF. Okay, so I'm going to need it. So I'm going to write it down over here and forget about it right now, and I'm going to look at the trinomial. All right, so I'm going to take my x method that I've been using. 2 times 5 is 10 because this is a times c. And then my b is 11. So what are the factors of 10 that will add and give me 11 and 10 and 1? Okay, so I always say circle those so we don't forget what we're using. And then to use the Berry method, we're going to need two binomials. And you're going to take this first term and you're going to write it twice without the square. Now, if you try to check this, 2 times 2 is not 2. We have an extra 2, but when we take that GCF out, it's going to take care of it. So we're going to add the 10 here and the 1 from our problem there. Now we're going to look at this first one and we're going to say, is there a GCF that will go into 2 and 10? Yes, 2. So when I take that out, I'm left with x plus 5. At this point, I don't need that 2 because I put in the extra 2. Remember, there's 2 there and I didn't need but 1. All right, so is there a GCF here? And that answer is going to be no, so that's going to be 2x plus 1. And then that's my final answer. All right, so hopefully that makes a little bit of sense. Okay, so let's look at this one here. And let's see what we can do. Is there a GCF? No. So we're going to take our x method, and a times c is negative 18, and then negative 3. Okay, we're going to come right over here. We're going to say negative 18. The factors 1 and 18, does that combine and give me negative 3? No. 2 and 9? No. 3 and 6? Yes. All right, so I'm going to put 3 and a 6. 3 times 6 isn't negative 18, though. So I need to ask myself, which one needs to be negative? When I add them together, I'll get a negative 3, and that will be the 6. Okay, so 3 times negative 6, negative 18. 3 plus negative 6 is negative 3. All right, so I'm going to take that first term, and I'm going to write it twice without the square. And then I'm going to take these factors, plus 3 minus 6. All right, this first one does not have a GCF, so I'm going to come down and write it down. But this one has a GCF of 2. So remember, we divide that out, and that's going to leave me x minus 3, and then I'm going to squish that. All right, again, stop your video at any time and try a problem, and this is a good one to try here. All right, so when you tried it, I hope you said x, and then 4 and 3. I have a negative 12 here, so I need one of them to be negative. This is a positive 1, so it should be a negative 3 and a positive 4. Okay, there's another video on differences of squares, so if you didn't join us in class for this, make sure you watch that video. Okay, so these first 3 are practice. So if you'll stop the video and do these first 3 where A is 1, I'm going to put the answers in and then come back and check yourself. Okay, so this should be x plus 6 and x plus 1. So 6 times 1 is 6, and 6 plus 1 is 7. All right, this one, since I have some negatives here, I know I'm going to have negative. Remember, you multiply to get this last one, and you add to get the middle. So the only way I can get a negative when I multiply is opposite signs. I know n times n. And then I'm going to ask myself, what are the factors of 18 that gives me 7? And that's 9 and 2. The 7 needs to be negative, so the 9 is going to be my negative, and my 2 is going to be positive. Okay. So this here, x squared minus 5x minus 6. So we have x and x, again, a negative there. So you're going to have a plus and a minus. And in this case, let's look at this together. So if you have negative 6 and negative 5, you might think 6 minus 1. That gives me positive 5. 1 minus 6. That gives me a negative 5. So it's going to have to be 6 and 1. Don't think 2 and 3, because 2 plus 3 gives me 5. But negative 2 minus 3 does not add, because we are adding to get that. And if a negative 2 times a negative 3, that would not be a negative 6. So be careful there. Okay, so let's look here at these middle ones. So we have 4x squared plus 5x minus 6. And in this case here, we can do our x method. 4 times negative 6 is negative 24. and then a 5 here. And so then that will give me 8 and negative 3. 8 minus 3 is 5. 8 times negative 3 is 24. So we're going to bring our 4x down. And then we're going to have plus 8 minus 3. So in this one, I have a GCF of 4. And that's going to leave me x plus 2. Again, I'm going to squish that one like a berry. And this one doesn't have a GCF, so I'm just going to write it down with my answer. Okay, here, do I have a GCF to start with? No, so I'm going to do the x method. A times c is 8, negative 9, so negative 8 and negative 1. Now these factors may not come as quickly, but you can stop the video and check. And then we're going to have 2m minus 8, 2m minus 1. Okay, so I need to look here. Do I have a GCF? Yes, a 2. That leaves me m minus 4. So I'm going to squish that like a berry. Does this one have a GCF? No. I'm going to write that down. I can do a quick check. M times 2m is 2m squared. And then negative 4 times positive negative 1 is positive 4. Okay, is there a GCF here? No. So I do my x method. 3 times 1, negative 1 is negative 3, and then a 2, so I'm going to get 3 minus 1. Okay, so I write down 3k plus 3, 3k minus 1, because I'm using these factors. GCF here, yes, a 3, so I'm left with k plus 1. Squish that like a berry. No GCF here, so I'm left with k plus 1 times 3k minus 1. Okay, last part in this video. So if you look in here, do I have a GCF to start? Yes, I have a 2. So that when I divide that out, I get this. Now this GCF here, I can't just squish like a berry. I need it to go back to the original problem. So I'm going to go down, write it with my answer. Okay, so 6 times 1 is 6 and 5. So 2 times 3 gives me 6. And 2 plus 3 gives me 5. So I have 6x plus 2, 6x plus 3. Here I can take out a 2, and that leaves me 3x plus 1. Squish that like a berry. Write it down here with my 2. Here I can take out a 3, and that leaves me 2x plus 1. Squish that like a berry and write it down here. I can do a quick check. 3 times 2 is 6, times 2 is 12. 1 times 1 is 2, times 2 is 2. All right, if I look at this one, what is my GCF that will go into 4, 12, and 16? Can take out a 4, and that will leave me x squared plus 3x minus 4. And then I need this, so I write it down. This has a as 1, so I can go ahead and factor. I know it's a positive and a negative, so I'm going to have a positive and a negative. I know x times x gives me x squared. The factors 4 would be positive 4 and negative 1. All right, you do this one. Reach out if you have trouble. Thanks for joining me, and please practice these. Very important.